Hello, and we are going to start in our next lecture, and we're going to talk about vectors and other variables. So we've talked briefly about being able to store values in a variable, but we've only talked about basically storing one number at a time in a variable, and that's cool, but it's not very useful. You're going to need to do a little bit more than that. So we're going to talk about storing numbers as something called a vector, and a vector is just kind of a list of numbers. We'll talk about data, storing data as text data. So say like you have a list of names or something like that, and then storing true-false data. And then finally, we're going to index vectors, so we're going to figure out how to get into them and use them. So this is some of the kind of the basic syntax, and syntax is just the rules of the language that you're going to need all the time. So this is going to be a good video for you maybe to review more than once. Okay, so let's keep going and get started. So the first thing we want to do is we're going to talk about creating a vector. Now to create a vector, we're going to use something called the combine function. And we're going to use this function a lot. So what the combine function does, is it combines a list of things together. Okay, and then it puts it into some kind of an object. And let's take a step back. I've called these things over here on the right-hand side, and notice right here how it's got this little greater than. That's actually a misprint. Okay, and it is HTML doing them a dirty. It didn't render this properly. There should be a dash there because that's the assignment operator. So don't let that confuse you too much. If you copy and paste this, which we will in just a minute, you're going to see it's not going to work. We have to correct that. So just remember, whenever you see something like this, that really means the assignment operator. Unfortunately, that's a problem with this textbook, and the way it's been rendered in the HTML that you see here is that it misses that. But moving on. So where are we at? We're going to use this combine function, and it just puts things together. And it can put numbers together. It can put text strings together. It can make lists of text. It can put vectors together. I mean, you can put all kinds of things together. It just combines stuff into an object. Now, what is an object? Well, that's a big question. In fact, in computer science, you can take whole courses on basically the idea of an object or object-oriented programming. We're not going to get into that. Basically, what we're going to say for intents and purposes of this class is an object is a box, all right? Or if you rather, a filing cabinet. And in that filing cabinet, you can put different kinds of stuff. Everything from numbers to text to functions, different procedures, how to do stuff. They're really, really useful, though we're not going to get into most of the usefulness out of them. We're going to treat them more like the what in computer science would have been called a record, right? Which is basically just a bundle of variables. It's a little more, objects are a little more cool than that, but we're not going to get into those cool features. But in general, this right-hand side, that's going to be an object of some kind that we can put different stuff in. Okay, now let's think about this just a little bit more. We're going to put this stuff into this variable over here, or object, and then we're going to do something with it. Okay, so easy peasy lemon squeezy. So let's go ahead, and I'm going to go ahead and pull up my RStudio Cloud. How do I do that? Come right over here, click RStudio Cloud. All right, so first of all, let's play around a little bit with the combine function and what it can do. So let's go here. We're going to add in our nice little R chunk, and let's put in here, and we're going to go the combine function. And this combine function is really important. We're going to use it an awful lot. So, for example, let's make a list of numbers. Let's go back to here, and let's just copy this. And we're going to find it's not going to work because let's just put it in and see what happens. And I'll show you. All right, error, sales by month not found. So what it wants to do is it wants to do a comparison of this object, sales by month, to this list that we've made over here. I'm going to call it a list. It's actually a vector A vector is just a list of numbers. Okay, but this object doesn't exist. So we want to change that from a comparison to the assignment operator, and it's just that little arrow, and bajinga. Bing, now we have a vector of numbers. And we come up here to values, and it comes here sales by month, and it's got numeric, so it's a numeric vector. It says it has 12 different entries, so 1 to 12 is its index, and then it gives you a list of some of the numbers in there. There you go. All right, easy peasy. That's what we've done. We've just made our first vector. Okay, that combine function, we're going to go back over and over and over again. Okay, I'll let you read your handy digression on your own. So let's get some information out of this vector. Well, first of all, we can index a vector, all right, by the element with inside it. So let's do sales. So I can come down here and use the autocomplete, select that and hit return. All right, sales by month. And then I'm going to use a square bracket. All right, just like that. So that square bracket, and let's say I want 2. So that's going to give me the second entry in that list of numbers or in that vector. Okay, and so let's do that. Bing, there I have 100. I could do a few of them. Equals, so let's do a colon in there, and let's go from 2 to 5. That's going to give me 2, 3, 4, and 5. All right, I can even do something really fancy, like for example, do this. I'm going to do sales by month, just like this. I'm going to copy this. And then I can come in here and I'm going to say Control V, sales by month again. Get rid of that. And I'm going to say not, that's the exclamation point, equal 0. Let's see what happens. Let me get that bracket right backwards. Supposed to go, and boom, it gives me the non-zero entries. So there's a lot of really cool things I can do once I have a list of numbers. Right? So this is the basic behind storing numbers as a vector. Okay, so a few useful things to know. Here's a great function. It's called length. That's going to tell you how long a vector is. So for example, if I want to know how long this vector is, I can do length. All right, and then I'm going to hit the tab button, and it says, okay, x equals. If I hit the tab button again, oh look, sales by month. Right, now there's only one argument to length, so I don't really need the x equals. And if you remember from last time, we kind of said when you have an x equals and that's the first argument, oftentimes we don't put that in there. We'll put all the other ones as named arguments. So we'll do it like that. Bing, and we come down here. What's the last one? 12. Why? Because there are 12 items in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you have just learned I can count to 12. All right, so there we are. Let's see, what else do we want to talk about from this section? There isn't too much. Okay, so we can do operations on this. So operations on vectors and matrices follow the linear algebra rules of matrices and matrix and vector addition, subtraction, multiplication, and division. In general, though, it's going to be element by element. So let's say I want to go in here. Let's do some vector math. Okay. All right, and what I want to know is I have 5 salespeople. So I've got sales by month, and I'm selling, and I have 5 people selling. I don't know why I have 5, but whatever. All right, so sales by month, and I want to know what that is per person, what the average amount of sales per month is. So I divide that by my number of sales associates, which is 5, and what do I get? Bing, each one of the individual numbers divided by 5. All right, well, wait a minute. What if I want to do this a little fancier? Let's say, let's do sales dot associates. I don't know if that's how you spell associates or not. Don't care. All right, and now what I need is I need 12 of them. So we're going to have 5 for the first 6 months. So 1, 2, 3, 4, 5. And then 2 for the last 6 months. 1, 2, 3, 4, 5, 6. Okay, let's run this. Oh, I missed one. I know that because I come up here, sales associates, it says 1 to 11. All right, so let's go ahead and we'll put in another 2. Great. And let's start out with 2 because that way it's, no, don't bother. Let's leave that 5. All right, you see that? How it gave me a parenthesis there? That's not what I wanted. That was that auto completion that I talk about sometimes. It's hard. Let's put 2 there. All right, so 2, 5, 5, 5, 2, 2, 2, 2. There you go. All right, so let's do that. All right, 12 and 12. Now, let's try this. Sales by month divided by sales associates. Let's try that. Bing. And what did it do? It's going to do element by element. So it's going to take the first element of, so 0, of sales by month and divide it by the first element of sales associates. Then it's going to do it the second, the third, and the third, and the third, and so on and so forth. That's the standard methodology for this. Now, if you think about these, if you know anything about linear algebra and matrices, you know that dividing by a matrix is a little weird. It's actually you're inverting that matrix. The division sign here is not going to automatically give you matrix inversion. It's always going to give you this element by element type of division. If you want more of the matrix algebra stuff, you'll have to use a function to do that. But for now, we're not going to worry about that because nothing in this class is going to require that. This is really just so you can kind of see how these vectors work. Okay, so there's some vector math and yada, yada, yada. Let's go ahead and let's talk about storing some text as data. All right, so what about text? Now notice here again, we've got this rendering error where it doesn't have the dash. Yeah, sorry about that. In any event, let's go ahead and let's store some text. The way we store text is by putting it in some kind of quotation mark. You can either use double quotes or single quotes. I personally find single quotes to be a little cooler than double quotes, but it literally doesn't matter. I mean, you know, it's just style, all right, which one you want to use. I tend to use single quotes in R just because I think they look cooler. But for right now, I'm not recopying all of these. Let's create a list, or this is also a vector of sorts. I think of a vector as numbers, but R would call this a character vector, or a list of, now I'm going to use a different word for this, strings. So you have character valued variables in R. In most of the rest of the world, those are called strings. And that has to do with how it's put together deeply inside the computer. So I don't want to go into why it's called a string, but I will often use the word string to talk about text like this. If you're used to Microsoft Excel, it always calls it text. Well, okay, fine. That's technically correct. I'm old and like the word string for it. To me, a character is just one letter, and a string is a whole bunch of letters. Oh, it didn't like me to do that. Oh, well. Let me copy this. All right, let's go back to RStudio Cloud, and let's talk about character vectors, or basically a list of strings. So a vector is just a list of something. Okay, and I'm going to paste this in, and I'm going to correct this so that I have that right there. And let's go ahead and type in month. O-M-O-N-T-H-S. So it prints it out. Let's do this. Run this. Hooray! There we go. We have our we have our months. Oh, and we can do some cool things like, for example, month. What if I want months and I want the fourth month? I can't remember which one is the fourth. I can't remember April is the fourth month. So we'll put in 4, right? Boom, it prints out April. Ooh, I want to go from 4 to 7. So from April to July. Bingo, there we are. And then, let's say I want, and then I could also do something like string comparisons and whatnot, that contains such and such. Like for example, I could do a search and get all the months that end in Y. I am not going to do that here. That's a little beyond the scope of the class. Those require some string comparison functions. It's not hard. It's just beyond the scope of what we're talking about in this class. So there we go. Bing, bing, bing. Okay, so let's work with some text. We can do things like the number of characters, so we could get how many characters are in a month. So let's do that real quick. Let's return the number of characters, NCHR. All right, number of characters. And let's put in months. Okay, and let's see what we get. Bing! So the first one, January, J, 1, 2, 3, 4, 5, 6, 7. There's 7 characters or 7 letters in the month of January. Bingo, and that's what it's returning. And so we get a vector that does element by element. So it counts the number of vectors in each element of this, or number of characters in each element of this character vector. All right, which is, kind of cool. If we wanted to say, we could also do a Boolean. So, less than 5. So how many months have less than 5 letters in their name? And so it says false, 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 true, true, true. All right, so it's returning false or true whether or not. So January has 7 letters in its name. That's not less than 5, so it's false. And then if we wanted to get really fancy, we could do months, put that in a bracket and say, give me all of the months who have less than 5 characters in their name, and May, June, July. There, what do you know? Isn't that cool? I don't know why you would ever want to do that, but now you know how. So let's keep going, and yay. So last thing, we just had a little bit of a segue to it, true-false data. Let's talk about that just a smidge. So if we're thinking about true-false data, we have some kind of comparison that's going on. Now this is kind of important. When we talk about comparisons, the first thing we want to do is we really want to talk about, and the one that gets used the most is the equality operator. All right, and notice it's equals equals. It's 2 equals. For the most part, with the exception of less than or greater than, all of your comparison operators are going to have 2 characters. All right. The principal exception is less than or greater than. And the reason for that is equals, the single equals, is already used as an assignment operator. And now what's the difference? A comparison operator compares each side. An assignment operator makes one side equal the other. It takes whatever's on the one side and puts it in the other. So in general, we want to use that arrow assignment operator. There are a few times, and the basic exception to that is when we're talking about arguments in a function. So those named arguments, those are always an equal. You never want to use the assignment operator there. But other than that, we're going to use the assignment operator, that arrow. For comparisons, though, the equality operator is equals equals. And so we can come in here, and let's change this one. I want to know all the ones who have exactly 5 characters in them. So let's do that real quick. And we have March and April, right, have exactly 5 characters. Let me get rid of this so it's a little clearer. Bingo. Now, what if I were to do something like that? Well, what's going to happen is unexpected equals. I don't know. It's going to say, hey, I don't know what to make of this. you really need a comparison in here, and you're putting this assignment operator, and I don't know what to do, is basically what R is saying. And so, big. Okay. Now, what if I wanted not equal? Well, if you're used to Microsoft Excel, you use something like this, right? The less than and then greater than. You know, it's not equal. It's not less than. It's not greater than. I don't know what that means. Microsoft Excel is the only thing that I know of, at least modernly, that uses that particular character. In most of mathematics, and in particular in computer programming languages, the exclamation point means not. So, or it's also sometimes called the bang symbol. So bang equals is not equals. All right. So if I do not equals 5, bing. Those are all the ones where it's not equaling 5, and that gives me these kind of comparisons. So if I go ahead and let's do this instead. I'm going to get rid of this part. And I just want to know all the months that don't equal 5. And I hit here and I say, okay, January has 7 and 7 doesn't equal 5, so that's true. So it evaluates true for there. True, false, false, true, 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 true. Now notice these are capital. This is something that's important. There's some special values in R. So I'm kind of call them special numbers. 2 of them are true. All right, notice how it changed color. I could also write it as just a capital T. What I can't do is this. Didn't change color, so it's wrong. I mean, it's kind of trying to say, are you sure? Basically saying, hey, stupid, don't you want to capitalize that so it's like this? All right. It has to be capitalized, and it's either a T or it's true spelled out. Either one of those are equivalent. So if I do true equal T, all right, let me get rid of these. What's going to happen? Let's run this. I get true because true equals true. Okay, next one is false. Notice when I got it all spelled out and all caps, it turns blue. So I can either do false equal false. Well, false does equal false, and so that true false statement actually evaluates true. So we have true and true. So true equals T in R, as long as it's all caps, and false in all caps equals F. And false means it's, well, not true, and true means it's, well, not false. All right, cool. All right, these can be really useful in different scenarios. And we won't get into huge amounts of this in this class, but in subsequent classes, like for example, if you took econometrics, there's some really useful things you can do with all this stuff. All right, great. And I believe we got one more chapter to talk about, or one more section to talk about in this lecture, and that's indexing vectors. And the thing is, there's several things we can do. We can actually use a combine function inside of the index of a vector to get special ones. That's fine. That works just fine. So if I just wanted the second, the third, and the fourth elements, I just use a combine function and get 2, 3, and 4. I can also just pass it another vector. I could put another vector in here because that's exactly what this is doing. The combine function is just giving it a vector. I could store that vector someplace else and then put it in. Okay, we got sales by month. That's true. Sales. Okay, that's all great. Whoop-de-doo, whoop-de-doo. All right, we talked a little bit about logical indexing, right? Sales by month greater than 0. That gives us February, March, April, May, right? We talked about that. That's cool. All right, so months, any sales this month. All right, if what we do is we store sales by month greater than 0, that's a logical expression, as any sales by month, then we're going to get a true, false like we saw before. We can pass that to months, and it's going to give us the number of the different months where we had positive sales. and so on and so forth. So all of this stuff is certainly possible. I'll let you read this on your own. We won't use tons and tons of it in this class, but maybe just a smidge. All right, talk to you guys in the next video.